Welcome back. Today we're going to be talking about theoretical probability. Our content objective is students will be able to find the probability of an event by using the definition of probability. Language objective is students will be able to use correct vocabulary when discussing probability. Why am I learning this? Well, it's important for real-world examples like finding your chances of picking or pulling out two same color socks from your drawer in the dark. Background knowledge. Please remember probability could be expressed as a number between 0 and 1, as a fraction, okay, 0 being impossible, 1 being certain, or sometimes we express it as a percent, okay, and 0 being impossible and 100% being for certain. So again, you can express it as a fraction or as a percent. Let's remind ourselves an event is the experiment is the activity in which we observe the outcomes. Each experiment is called a trial. Okay, so experiments would include flipping a coin or rolling a number cube. The outcome is what the result is from the event. So the sample space is all set of possible outcomes. So in this case, the sample space would be heads or tails, and rolling the number cube would be 1, 2, 3, 4, 5, or 6. So probability describes the likelihood of an event will occur. So probability is basically the number of desirable outcomes over the total number of outcomes. There's theoretical probability is what should happen, and then there's experimental probability is basically what ended up happening through the experiments, through the trials. Okay, so again, it's what we It's what we expect in theory to happen, that's theoretical, and then experimental is what actually happened. So here, the event is going to be spinning the spinner. The sample space, so what are the different possibilities? Well, it's 1, 2, 3, 4, 5, 6, 7, or 8. Those are the different outcomes. So probability, again, just a reminder, is the number of desirable outcomes over the total number of outcomes. So here, what's the probability of rolling a 3? Well, first we're going to look at the number of desirable outcomes. Well, I'm looking just for 3. So how many ways could I spin a 3? There's only one way, so that's going to be a 1. Well, total number of outcomes. How many total outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So my answer is going to be 1/8. Okay, so now what about the probability of of spinning an even number? Well, let's see. First, we're going to look at the number of desirable outcomes. We're looking for all even numbers, so 2 is even, 4 is even, 6 is even, and 8 is even. So how many possible ways was there? 1, 2, 3, 4. So I'm going to go ahead and write 4 out of a total of how many outcomes? Again, there was 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 4 out of 8. But we can reduce both by a 2. Oops, not a 2. We can reduce both by a 4. And you're going to end up with 1/2. So our probability of spinning an even number would be 1/2. So notice, we break it down to the number of desirable outcomes, how many ways could we get it, and then we divide it by what are the total number of outcomes. So basically, this number of sample space. Okay, so using the same spinner, now they're asking us, okay, what's the probability of getting a number less than 6? Well, we can spin a 1 is less than 6, a 2 is less than 6, a 3 is less than 6, a 4 is less than 6, a 5 is less than 6. Is 6 less than 6? No, so we're not going to include that, neither is 7 or 8. So how many ways could we get a number less than 6? Well, if we spin any number between 1 and 5, so that's 1, 2, 3, 4, 5 different ways. Well, how many total outcomes were there? Again, count 1, 2, 3, 4, 5, 6, 7, 8. So the answer is going to be 5 out of 8, and it is reduced, so that's it. Okay, so now what about a composite number? Ooh, this one's tricky because you need to know what a composite number is. A composite number, by one definition, is it's any number that's not prime or 1, or it's basically a number that can be made by multiplying two numbers that's not 1 and itself. So here, 1 is not a composite because it's neither prime, it's called a unit, or composite. Number 2 is not composite, is considered prime. 3 is also prime, so it's not composite. 4 is composite. Why? Because 2 times 2 gives me 4, so notice the numbers didn't include 1 in itself. 5 is prime. The only factors are 1 and 5. 6 is a composite because we can make 2 times 3 gives me 6. Okay. 7 is prime. 8 is composite because we can say 2 times 4. So that's an example of factors that don't include 1 in itself. So how many ways did we get a composite number? There was 3. And how many outcomes? A total of 8. So it's going to be 3/8. Okay, so now let's take a look here. It says a bag consists of 3 reds, 4 whites, and 2 blue marbles. Find the probability of each of the following. So here is just a quick visual of the different marbles we have in the bag. What's the probability of getting a red? Well, let's see. How many reds are there? 1, 2, 3. So there's going to be 3, but out of a total of how many? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 3 out of 9. We can definitely reduce that. You need to reduce whenever possible. If you put 3 9s on your homework, you will get it wrong. So please make sure to reduce your answer completely. Okay, what is the probability of getting blue or white? Well, let's see. Blue or white. So there's 1, 2, 3, 4, 5, 6. So there's 6 ways to get either white or blue. But again, there's only 9 total, so it's going to be 6 out of 9. Again, reduce whenever possible. I'm going to divide by 3, leaving me with 2/3. So that is my final answer. Okay, next one. What's the probability of getting a purple? Well, let's see. There are no purples in this bag, so I'm going to say 0 out of 9, which gives me just 0. And remember, this is called an impossible event. There's no way I'm going to draw a marble from this bag and it be purple, because the only colors are white, red, and blue. So now, if you want all your probabilities to be equivalent, what could you add or take away from your bag to make that a possibility? So basically what it's asking is they want it to be an equal chance of getting white, an equal chance of getting red, an equal chance of getting blue. What do you think? Go ahead and brainstorm. Okay, so let's take a look at some possibilities. One possibility is to make sure all of them have 3 marbles each. So 3 whites. So let's take away 1 white. There's already 3 reds, and we would have to add in a third, 1 extra blue. So one way would be to take away a white, but include a blue. Are there other possibilities? Well, let's see. We could make sure there's 2 of each. So maybe take off 2 whites, so there's only 2 whites left, and 1 red, so that there's 2 reds left. So that's a possibility. Let's think of one more possibility, because trust me, there are multiple answers that would be right. Let's say, if we wanted to keep 4 of each, we can include 1 more red to make that 4 red, and then 2 more blues to make there a total of 4 blues. So that's a possibility. But please note, there are multiple answers, okay, as long as you make sure that there's an equal amount of white, an equal amount of red, and an equal amount of blue. Moving on. So here it says, a letter is chosen at random from the word algebra. Find the probability of each event. So here, what's the probability of getting a G? Well, let's see. How many ways can we get a G? There's 1 way. There's only 1. So we're going to put 1 out of, well, how many different letters are there to choose from? 1, 2, 3, 4, 5, 6, 7. So it's going to be a 1 out of 7 chance. Okay. What about an A? Go ahead and pause the video and try this one by yourself. What's the probability of choosing an A? Well, let's see. Hopefully you recognize there's 2 A's. So it's going to be 2. But out of how many letters? Again, 1, 2, 3, 4, 5, 6, 7 letters. So it's going to be 2 out of 7. Okay. Now I'm going to challenge you. What about the probability of getting an A or a B? Go ahead and try that by yourself. Okay, so I'm going to circle all my chances. I can get this A, I can get this B, I can get this A. So altogether, there's 3 desirable outcomes. And it's still out of 7 because algebra still only has 7 letters, so it's 3 out of 7. Notice I didn't have to reduce any of these fractions, and that's why I was able to just state that as my final answer. Next, okay, now the very last challenge. I want you to try the probability of not an E. Okay, so let's see how well we did. So that means I can choose any letter as long as it's not an E. So A would work, L would work, G would work, E will not work because they're saying not E. B would work, R would work, and A would work. So that's a total of 1, 2, 3, 4, 5, 6 possibilities out of a total of 7 outcomes. Okay. So now I want you to create a word that will result in a 50% probability when choosing any letter individually. Okay, so let's see. What did you think of? Well, I'm going to go ahead and share the ones that I thought of. I'm just going to go ahead and make it easy and say maybe something like it. There's a 50% chance of getting an I, a 50% chance of getting a T. Are there other words? You can pick another 2-letter word, which is on. That would work. Now, could you think of a 4-letter word that would also work? 50% chance of choosing any letter. I'll let you think about that. Okay, so now moving on. It says, a standard deck of cards contains 52 cards. There are 4 cards in each suit. Clubs, which looks like this. Diamonds, which looks like this. Hearts, which looks like this. And then spades, which looks like this. The cards are ranged from 2 up to an ace. So here, from 2 all the way to an ace. What's the probability of getting red? Well, let's go ahead and count how many reds there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So there's a total of 26 red cards, but out of a total of how many cards? Well, here I'm not going to count. It just tells me there's 52 cards altogether. Now I'm going to go ahead and reduce, okay? I'm noticing first of all, I'm noticing half of them are red and half of them are black. So I can know right away I can reduce by 26. But some of you may not see that, so I'm just going to go ahead and divide by 2 because at least I can see that they're both even. That would leave me with 13 over 26. But then hopefully you recognize that you can reduce by 13, which would leave you with 1/2. But again, I want you to see that half of the deck is red and half of the deck is black. So my final answer is just 1/2. Okay, so now what's the chances of me getting a jack? Well, there's a total of 1, 2, 3, 4 jacks, okay, out of a total of 52 cards. So now please make sure you reduce. I'm going to check if we can reduce 52 by 4. Let's see, 52 divided by 4. Does that work? Yes, it does. It's 13. So I'm going to go ahead and divide by 4. And that's going to leave me with 1/13. So my probability is 1/13. Okay, so let me just clean this up a bit. I'm just going to go ahead and rewrite this as 1/13. 1/13. Okay, what's the probability of getting a 12? If you look very carefully, it goes from 2 all the way to 10, and then it goes Jack, Queen, King, Ace. There are no 12s in sight, so we're going to go ahead and say that's 0 out of 12, which is just 0, which means it's impossible. Okay, what's the probability of getting a 5 or a 10? Well, let's see. There's 5s here. There's 4 there altogether. And then there's 10s here. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of 52 chances. I note that I can reduce by 4 because I saw that earlier, so I'm going to divide by 4, leaving me with 2 over 13. So that's my probability. I'm going to go ahead and just clean this up and put 2 out of 13. Okay, so now what's the probability of a card less than 6? Okay, well, we have to first look what numbers are less than 6. 5, 4, 3, and 2. So all of these fulfill the requirement. Okay, up to here. Whoops, there you go. We don't want to include 6 because 6 isn't less than 6. Okay, so let's count how many we have. There's 1, 2, 3, 4. 1, 2, 3, 4. 4 by 4 means it's 16. So there's 16 out of a total of 52. Right away, I know I can divide by 4, which is going to leave me with 4 over 13. So it's 4/13 probability. Now the last thing we're going to talk about are complementary events. The complement event is the opposite of that event. So for example, if I say the probability for a storm to happen on the weekend is 2/7, so the probability of no storm on the weekend would be 5/7. So if you notice, why is it 5/7? Well, if 2 out of the 7 is yes, there's going to be a storm, then there's a 5 out of 7 for it not to be a storm. And one way to check is they should both add up to a whole. So 2 plus 5 is 7, and since they're in sevens, we're going to keep that, and it does equal 1. Okay, so notice both of them should add up to one whole. Okay, so here, the probability of it raining is 30%. So let's think. This has to, because we're talking about percents this time, it should equal a total of 100%. So if 30% of it, there's a good chance it will rain, then I would say 70% of it, there's a good chance it will not rain. And how do I know it's 70? Because 30 plus 70 is 100%. So please notice the complement is the number that will make the other number add up to 100. Okay, so when we're looking at fractions, it equals 1, but if we're talking about percent, it's going to equal 100%. So keep that in mind. They're slightly different. It says, give the probability for each outcome. The basketball team has a 55% chance of winning. What is the probability that the team lost? Well, first we need to recognize, hey, what was their probability of winning? Their probability of winning was 55%. Okay, so what was the probability of them losing then? Well, let's remember, both of these should add up to 100. Okay, so they're asking us to find the complement of 55%. Well, for certain, it should be 100%. So what I'm going to do is take 100% and minus 55%. Okay, that here, if you want to, you can convert it into a decimal and say this is 1 and this is going to be 0.55 and do the math, and you would get 45 hundredths. Or you can just say, hey, 100 minus 55 is 45%. So if 25% chance of them is, sorry, not 25, if there is a 55% chance of them winning, then I would say there is a 45% chance of them losing, because both of these should add up to 100%. And I know I'm right, because if I add 45 with 55, it does give me a total of 100. Okay, so now we're going to find the complement of each of the following. Okay, so please remember, it's either going to equal 1 or it's going to equal 100%. Here, since it's a decimal, we know it has to add up to equal 1. So I'm going to go ahead and do 1, let's do it like this, 1 minus 25 hundredths. I can do this in my head because I think of money, so it's going to be 75 hundredths is my complement. Here, 72%, well, since it's given as a percent, I'm going to do 100 minus 72. Okay, because they should pair up to give me 100, and that's going to give me 28%. Here, 3/8. The complement of that, well, first it's going to stay in eighths, but it needs to add up to 1. So 3 plus what will give me an 8? 5. So notice here, I have 5/8. But you could have also done this. You can have said, okay, 1 over 1 minus 3/8, and then done the math, and you still would have gotten 5/8 as long as you got a common denominator. And that would give you the same answer. Okay? But I like to do it this way, say, okay, it's going to be an 8. How do I get 3 to make an 8? It would be 5. So now I would notice that 3/8 plus 5/8 does give me 8/8, which is what I needed. Okay. So here, if the probability of you winning was 7 out of 9, the probability of you losing would still be out of 9. But how do we get 7 to become 9? We would have to add 2. So the probability of losing is 2 out of 9. Now, if I wanted to check to see if I was right, I would add these two together and make sure it does equal 1, which it does, so I know I'm good. Okay, so here, what's the probability of you landing on blue? Well, it's 17.2%. So the probability of you not landing on blue is going to be 100 minus 17.2%. I'm going to do the math, and that's going to be about 82.8%. Now, how can I check to see if I'm right? Well, I can add these two together, 82.8 with 17.2. I should end up with 100%, and I do, so that I know I am right. Okay. And then last but not least, here, the probability that you can't go to your friend's house is 1/1500. So the probability that you can go to your friend's house, well here, notice, it's not going to equal 100, it's going to equal 1. So I'm going to do 1 minus 1/1500, which is 8500. But again, I should probably check to see if I'm right. I'm going to do that by simply adding 8500 to check to see if it does give me a total of 1. And guess what? It does. So I'm pretty confident that that is my answer. So that is actually going to conclude the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.